Alright, hello once again, Jeff Scott of Rankin Technical College. As part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD1100 C# Programming Fundamentals class, I've been doing a series of video presentations based on the textbook that's going to be used for that class, that textbook being Muroc C# 2015. I'm doing both a series of lectures on the PowerPoints for the book, and I've done the first 7 chapters that you can see right here, and I'm toward the end of Chapter 8. I'm also doing 2 what I like to call perpetual payroll programs, meaning that with each program I'm trying to introduce concepts that were explained in the associated chapter. And I've been doing the payroll program in 2 ways. One is a console app, and the other as a GUI, or graphical user interface application. So as mentioned, I'm in the middle of Chapter 8, how to use arrays and collections. We pretty much talked through arrays and we're into collections. Alright. So here's an example, as it says, of code that inserts and removes elements from a list. This would make a new 0 or first element, and that would be the value. Now, if I do this, what should happen is if there already, let's say there's already 5 values in a list. All right. This does not replace what's there. This becomes the new first element, and the former first element moves down and now becomes the second element. All right. So notice how you can use these in a way very similar to arrays. All right. So they're assuming that sales 1, 2, etc. have these values. Then they give you code. And again, since you are not changing the values, we can use a for each. So notice sales totals is the name of our list. All right. And for each decimal D, those are the values. It's just going to print out the values that are in there. 27, 45.73, 32, etc. Code, as it says, you can check to see if something is in a list. So notice there's 2 things that are happening here. This first line is seeing if sales totals contains X, which is this. It does, so it'll tell it to remove it. Here, if you look, we had values. They're not in any kind of order. Then they're in the order we put them in. And then we remove 27, 45, 73, so we remove the first one. Then we're saying take what's left and put it into order by using a sort. Then we can use a binary search to see if something does or does not exist, and if it does, where it is. When you work with a sorted list, as mentioned here, here are some of the common properties you can use when working with it. Again, most of them, hopefully at least, are something you've either seen earlier in the chapter or that you can look at and say, oh, that makes sense. All right. So what's the difference between a list and a sorted list? The sorted list has been sorted. So it's in some kind of order. Okay? And I see no reason why you couldn't run sort on it and then run a reverse method on it to make it in descending type of order. Because by default, sort will put it in ascending order. Now, the way all this stuff works is through what are called key value pairs. Key value. So when you go through a list, you can print out the keys, you can print out the values, or you can print out the keys and the values. So for instance, when we look right here, All right. Maybe these are customers. So it's P. Finkel, A. Adams, E. Potter, and L. Lewis. Maybe this is the amount of sales they've had for the month or whatever. All right. So notice how we're adding these. Because you might look at it and go, wait a minute, string decimal. Yeah, it says we're going to have a string followed by a decimal, and there will be 4 of them. String decimal, string decimal, string decimal, string decimal. You can do it like this, or you can use an initializer, which is very similar to the way we initialized arrays before. But again, string decimal, string decimal, string decimal, string decimal. You can also, as it says, use an index initializer inside a collection initializer. Some people find this easier because it's saying P. Finkel equals this, A. Adams equals this, E. Potter equals this, J. Lewis equals this. So any of these would work. When you start working with keys and values, there's even more stuff that you can do. The first example there shows code that looks up a value in a sorted list based on a key. The second one, as it says, converts the sorted list to a tab delimited string. So it's name, tab, value, name, tab, value, name, tab, value, name, tab, value. There are a lot of things you can do with this, as you might well imagine. All right, let's talk for a second about the Q class, because people sometimes get confused with this kind of stuff. All right, imagine that it's the first day of class, and let's say you're going to be a student at Rankin Technical College. Now, the campus I work at is a small campus. It's an off-site campus from the main campus in St. Louis. All right. We don't have a bookstore, but let's assume that we're going to the St. Louis campus, which does have a bookstore. So the bookstore opens, 10 people come in to purchase books for, let's say, their C# programming class. And the 10 people come in, and basically in a random order, they go, so again, keep this simple. So 10 people come in. All right, let's forget about these examples we looked at before. But 10 people come in. We're just going to say they're person 1, there's 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now they buy their stuff. Some people have got more than one book to buy, etc. So the first person ready is person 9, then person 4, then person 6, then person 10, then person 1, then person 3. Then person 2, then person 7, then person 8, and then person, who am I missing, 5? All right, so this is the order that they come in. It really doesn't matter, but this is the order they're in line to be checked out. With a queue, the first person in line, all right, is the first person to be checked out. And that's the way lines work. You go to the movies, and there's 3 people in front of you to buy popcorn. You don't just yell from being the 4th person, like, hey, get me a popcorn, and they wait on you. No. They'll wait on customer 1, then customer 2, then customer 3, then they'll wait on you. It's the same way here. So with a queue, it's also known as a FIFO type of structure. The first one into the queue is the first one out. All right. Now imagine that you're at the cafeteria at the Rankin St. Louis campus. All right. And they just ran out of trays. So the person in there puts 10 trays in. They put in tray 1, then they put in tray 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10. But that's not, if that's the order they're put in, technically then, tray 10 is at the top, then 9, then 8, then 7, then 6, then 5, then 4, 3, then 2, then 1. So unlike a queue, which is a FIFO structure, The other type of structure that people work with is a Lifo structure, and that's called a stack. So you pop things off in the reverse order that they're put in. So imagining that all the trays are clean, etc. If the cafeteria person puts 10 trays down on one of those spring mechanisms, they'll put down number 1, then number 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10. So 10 will be the first one that gets popped off. All right? Why did I tell you that? Just so you have some kind of an idea, if you didn't before, of what we're talking about here. All right? Get rid of these. So these are different things then that you can do with a queue. You can end queue to add things to the end. That's like a new person coming in line. You can dequeue, which means like service the front person in line. You can remove everything from the queue. You can do what's called peek, which allows you to see what's next, like you could see who's next in the line without waiting on them, or in this case, without deleting it. So here's how you could create a queue. Notice, first in, first out. Stacks I've already mentioned. So when you put something, so if you put a new tray on top of the stack, that's a push. When you take the top one off the stack, that's a pop. Clear does just that, and peek is what we looked at before. So again, here's code for queuing. Here's code for stacking. Notice here it's in FIFO, or first in, first out. Bain, Martinez, Muroc. Here it's in the reverse order of that. Muroc, Martinez, Bain. All right. Again, we talked about array lists before. For whatever reason, they jump back to that. They're giving you some more examples. Okay. That pretty much is it. Okay. So in just a couple moments, I'm going to come in and start on Chapter 9. Chapter 9 is on dates and strings. Now, two things. First, you say, well, we've already talked about strings. Yes, we have. But strings have some built-in methods that we have not yet discussed. I do want to mention one thing, and that is if you go out to Msdn, which stands for Microsoft Developer Network, .microsoft.com, all right? So let me make this a little bigger so you can see it. That's all you need. Msdn.microsoft.com will bring you all to the Microsoft Developer Network. It pushes you off now. They always change this, but that's fine. It'll get you there. And you're like, who cares? Well, I can come in here and I can search for example, C# strings. And notice if I want all the C# string functions, I can put that in, and boom, it'll point me to string, and in here, among other things, you know, again, I might have to search in here a little bit. String methods. For a list of string methods, all right, but it's your go-to place. It's your go-to place to find out anything C#. In fact, a lot of times if I come into Google and I type in C# string methods, what I'll find is at the top or near the top will be exactly what I just showed you. Now here it's got docs.microsoft. You can get there from where I showed you. All right? So you can get there and boom. It's the same site, but just a different part of it. All right, so I'm going to finish up right now and start with how to work with dates and strings in just a couple moments.